Hello everyone, so today we are going to discuss TCS NQT set 5. So without further ado, let's begin. So basically we are with our first problem. An international roundtable conference will be held in India. Presidents from all over the world, irrespective of the countries, will be attending. Task is to find the possible number of ways to make n people sit around a circular table such that the President and Prime Minister of India will always sit next to each other. So yeah, pretty standard problem. You're given the value n and you have to output a value, possible ways of seating the numbers. So basically a very simple problem, as you all might be aware that in a circular permutation the total number of ways to make a person seated are n minus 1 factorial. Now let's consider the scenario 4 only, in which one is a PM, one is the President of India, one is from America and one is from France. So yeah, we have to make these people seated so that these two people always sit next to each other. Since they are always sitting next to each other, we can consider them as only a single entity. So let's name this single entity as India. So now we have to make these people sit around a round table. So basically we have to seat three people around a round table. So there are 3 minus 1 factorial ways for this. This is 2 factorial, and since the PM and president are a single unit, but the PM and president can have two different combinations in sitting next to each other, like the PM can be the first sitting and president can be at the second position, or the president can be the first position and PM is at the second position. So yeah, these are two different ways. So we also have to multiply to 2 factorial here, because there are two different ways. So yeah, pretty straightforward problem. Here we are doing 3 minus 1, which in our terms 3 can be represented as 4 minus 1 minus 1 factorial into 2 factorial. 2 factorial is always 2, and 2 into 2 equals 4 in this case. The solutions formula will become n minus 1 factorial into n minus 2 factorial into 2 factorial. Pretty standard question for considerably low inputs, like we can have our input max till 20, I guess, after which integer overflow occurs. We'll already be taking long in our approach. This approach can also be solved using strings if our n's value is greater than 20. So yeah, using string multiplication we can also solve this in real test, but since our constants don't fall in that category yet, we are not using string multiplication. So yeah, C in n, and for int I starting from 1 till n minus 2 I plus plus. Here we are taking a product, p into equals I, c out p times 2. Okay, so let's take up longs, because we are already going beyond our limits. Let's try it for 4. So it's giving answer 4. Let's try it for another example 10. So yeah, it's giving a good answer. Let's check if it works for 15 as well. 15 is a very large number. It's working fine. Yes, till 15 it will work fine. So yeah. So yeah, pretty easy problem. Now let's move towards the next problem. So an agency has received report about some threats. Consists numbers in mysterious. There's a number n and another number I. Those numbers studied thoroughly concluded that all the digits in the number n are summed up, and this action is performed r number of times. The resultant is also a single digit that is yet to be deciphered. The single digit of the given by repeating r number of times. If the value of r is 0, print the output as 0. So yeah, this is uh, a Not a very good point because this is only an exception. So basically, will not be adding any number multiple times. So yeah, you just have to do whatever they say. Let's take the input of n. Also, instead of long we can go int, but long works fine as well. Int r, cnr, and first of all, let's sum up all the belongings of n. Okay, so let's do it using a while n s plus equals and mod 10. As you might be aware of a similar problem that has occurred in previous sets, we're using this. After this, less than r, we have to add the number r times. Let's pick a resultant. Resultant will be adding s to the resultant, and after the resultant is obtained, we have to obtain a single digit from it as well. So uh, let's try to understand that what will happen and what are the constraints. Constraints are n is still 1000, so and r is still 50, so anything can happen. So uh, while our resultant is here, or even let's pick up an answer as 0. Let's if my r is 0, I'll be just printing my 0 only. Else, in elsewise case, our answer can range from 1 till 9. So we'll be checking while ans greater than 0, and my ans value should be less than 9 as well, less than or equal to 9. Okay, so why my ans is less than or equal to 0, or ans is greater than 9, or my ans is greater than 9 means we are not in the valid constraints for a single digit number. Like initially our ans is 0, so what we'll be doing is we'll be doing this while okay, so let's just initialize ans to res only. It will make our lives easier. While ans, oh no, let's just do this only. Res, while res ans plus equals res mod 10, starting from 0. Ans plus equals res mod 10, res by equals 10. After it, we'll be receiving something. We'll be setting our res to ans. After all of this, when all of these conditions are done, we can just print our resultant. So yeah, let me just run some test cases, and then we'll be discussing how it's gonna work. Okay, it's 3 only. Put a wrong number. Yeah, it's giving fine. 1 2 3 4 and 2. It should give 2. So yeah, let me explain what is going on over here. So basically, firstly we are doing whatever the question says. We are adding all the digits of n r times, and after that we are getting a resultant. So what we need to do is we need to convert this resultant into a single digit number, right? But the resultant might contain different digits like 2 3 4 7 5 8 9. like this. uh, After adding all of these digits, I might get a number that might contain two digits. After that, I'll also have to do it. So to automate this process, I am using this thing. If r is 0, we are just printing 0 as the question said. Else, our resultant will always be between 1 and 9. So I'm checking if while my resultant is not in the range, like if my resultant is greater than 9, or we can also skip this because our resultant is always greater than equal to 0. While my result is greater than 9 means this is greater than a single digit number. So what we are doing is we are just adding the digits of resultant, and we're just adding the digits of resultant and uh, putting them in our answer, and after that we are putting the resultant as answer. So basically, after this, adding all of these digits, I might get something. This is initially answer, but after getting the answer in the while loop, I'm setting the answer to be res, so that we can repeat the loop once again. So yeah, pretty standard problem, a little bit tougher than all the previous problems in this sequence. So yeah, all the best.